Hello students, in this video we are going to discuss the problems on solution of non-homogeneous PDE by direct integration method. It's a continuation of the previous video. Okay, I will consider the first problem like this. Solve dou square z by dou x into dou y is equal to sin x into sin y, for which dou z by dou y is equal to minus 2 sin y when x is equal to 0 and z is equal to 0 if y is an odd multiple of pi by 2. Okay, odd multiple of pi by 2 means generally odd numbers can be expressed as 2n plus 1 and multiple of pi by 2 means 2n plus 1 into pi by 2. Okay, so in the previous video we done the problems without conditions. Now they are given the conditions, we have to make use of this one to find the values of the arbitrary functions. Okay, so and here now onwards give the order of the integration is very much important. That depends on the given condition. If the condition they are given as with respect to y, that is dou z by dou y they are given, means you have to integrate with respect to x first. Okay, if they are given dou z by dou x means you have to integrate with respect to y first. Okay, since here the dou z by dou y given, I am going to integrate with respect to x first. According to that, I will rearrange the given equation as dou by dou x of dou z by dou y into sin x sin y. Okay, integrating 1 with respect to x, treating y as a constant, will get dou z by dou y is equal to minus sin y into cos x plus f of y. Call that as equation number 2. Now integrate with respect to y, treating x as a constant, will get z is equal to cos x into cos y plus capital F of y into g of x. Call that as equation number 3. Okay, now I will use the first condition, that is dou z by dou y is equal to minus sin 2y when x is equal to 0. Okay, observe carefully here. So I can able to use this condition in equation number 2 only. So substitute dou z by dou y as minus sin 2y and x is equal to 0, we will get the value of f of y. Okay, that is f of y is equal to, will get minus sin y. So make use of this equation to find the value of capital F of y. You just integrate that one, will get f of y is equal to cos y. So using that in equation number 3, will get z is equal to cos x cos y plus cos y into g of x. Call that as equation number 4. So use another condition, that is z is equal to 0 at y is equal to 2n plus 1 of pi by 2 to find the value of g of x. Okay, so we will get g of x is equal to 0, since the value of cos of 2n plus 1 of pi by 2 is equal to 0. That means cos pi by 2, cos 3 pi by 2, cos 5 pi by 2, all the values are 0, means cos pi by 2 with an odd number always will give the 0 only. We will get g of x is equal to 0. Therefore equation number 4 gives z is equal to cos x into cos y plus cos y is your required solution. Okay. Now consider the second problem. Solve dou square u by dou x dou t is equal to e power minus t into cos x, for which u is equal to 0 when t equal to 0 and dou u by dou t equal to 0 at x is equal to 0. And also they are asking us to show that as u tends to sin x and when t tends to infinity. Okay. Since the condition with respect to t they are given, so I will going to integrate with respect to x first, keeping t as a constant. So we will get e power minus t into sin x into plus f of t. So again integrating equation number 2 with respect to t, treating x as a constant, we will get minus sin x of e power minus sin t plus capital F of t plus g of x. So use the first condition, that is dou u by dou t equal to 0 at x equal to 0, then in equation number 2 if we use, we will get the value of f of t that is equal to 0. That means just I am substituting dou u by dou t is equal to 0 and x is equal to 0 means sin 0 will vanishes, therefore f of t equal to 0. Therefore if it means by using this value capital F of t also will get 0, since integral of 0 is equal to 0. Substituting this in equation number 3, we will get minus of e power minus t into sin x plus g of x. Now use another conditions to find the value of g of x, that is u is equal to 0 at t equal to 0. Okay. Using this we will get g of x is equal to sin x. Substituting in equation number 4 and take sin x as a common factor, we will get the final solution as sin x into 1 minus e power minus t. And also they are asking to show that u tends to sin x as t tends to infinity. Suppose substitute t is equal to infinity in the above expression. What you will get? E power minus infinity is 0, we will get straight away u is equal to sin x. The same thing you write that one. As t tends to infinity, e power minus infinity tends to 0, therefore u tends to sin x as t tends to infinity. The next problem. Solve dou square z by dou x square is equal to x into y subject to the conditions dou z by dou x is equal to log of 1 plus y when x is equal to 1 and z is equal to 0 when x is equal to 0. Since the independent variable is x only given, so integrate with respect to x twice, we will get dou z by dou x is equal to x square y by 2 into f of y. One more time integrate with respect to x only, we will get z is equal to x cube y by 6 plus x into f of y plus g of y. Okay. Now use the conditions to find these values, that is f of y and g of y. I will use the first condition, dou z by dou x is equal to log of 1 plus y at x is equal to 1. So equation number 2 becomes, so wherever dou z by dou x is there, substitute log of 1 plus y and x is equal to 1, we will get f of y is equal to log of 1 plus y minus y by 2. Okay, substitute this one in equation number 3, we will get x cube y by 6 plus x into log of 1 plus y minus y by 2 plus g of y. Okay. Second condition, z is equal to 0 at x is equal to 0, therefore we will get g of y is equal to 0. Since log 1 is 0, all the terms will vanishes. We will get g of y equal to 0. Using that in equation number 4, we will get the final solution. Okay. So the next question. Dou square z by dou x dou y is equal to x by y subject to the conditions dou z by dou x is equal to log x when y is equal to 1 and z is equal to 0 when x is equal to 1. Okay, here condition with respect to x given, so that I will integrate with respect to y first. Okay. So integrating with respect to y, we will get x into log y plus f of x, and again integrating with respect to x, treating y as a constant, we will get z is equal to x square by 2 into log y plus capital F of x plus g of y. Okay. Now use the first condition, that is dou z by dou x is equal to log x at y is equal to 1. Using this in equation number 2, we will get f of x is equal to log x. Okay. Use this value to find the value of capital F of x. You have to integrate log x, we do not have direct formula. You have to consider the term as log x into 1 and apply the integration by parts, taking u is equal to log x and v is equal to 1, we will get f of x is equal to x log x minus x. So equation number 3 implies z is equal to x square by 2 into log y plus x log x minus x plus g of y. Also given z is equal to 0 at x is equal to 1. Using the equation number 4, we can able to find the value of g of y. We will get 1 minus 1 by 2 of log y. Okay. Substitute the g of y in equation number 4, we will get the final solution. Okay. So now based on this, I given the 2 assignment questions. Along with that, whatever I given the solution, the first 4 problems you need to practice and you need to include in the assignment also. And the question number 5 and 6 goes like this. Okay. So careful about the first question is straightforward. What we done in the first question, the same thing, the conditions are different, but second question carefully observe here, z of x comma 0 and dou z by dou t of 0 comma t they are given. That means the value of z is equal to 0 at t is equal to 0, the value of dou z by dou t equal to 0 at x is equal to 0. In general, it is x comma t, the first value represent x, second value will represent t. If x is there means I am not changing the x, only the t value is changing, that is t is equal to 0, z is equal to 0, x is equal to 0, dou z by dou t equal to 0. For your convenient, I specified the answers also here. So you have to arrive at these 2 solutions. Carefully work out all the 6 problems, that is. And in the next video, we are going to discuss the solution of homogeneous PDE. Thank you.